Okay, so welcome to the second video. In this video, we want to confirm something. We want to check if an asset can be liquidated. How do we know if an asset can be liquidated? I think I've gone over this before, but let me see if I can show it to you like I did. Here. Nope, it's not there. That's fine. Anyway, so in simple terms, let me show you this. So this is our loan parameter. If you recall, at the time when we're creating the loan, we store the liquidation price. The liquidation price is the price at which the loan is no longer viable. Okay, and it's like it's the price at which the liquidation threshold has been triggered. If we come to the market at the time where we call borrow, you see we get the liquidation price, and the liquidation price is simply the liquidation threshold multiplied by the asset price divided by this. This is a pure function. I mean, we can calculate this on the fly, but it's often helpful to store this, so we read from storage. So when can be liquidated? Okay, let's call this, let's say liquidation price. Okay, and let's say current price. All right. Actually, let's do this. Boom. Okay. Let's choose AVAX as our asset. So currently AVAX is around $20. Let us assume that the liquidation price for AVAX is, okay, let me give it okay, so $20. Okay, actually, let me add one more column. Price at borrow. Okay, let's say the price at borrow was 24. Okay, and let's say the liquidation threshold here. Okay, let's put that in there. Okay, let's assume this is 75%. Okay, all right, cool. So let's make this $1. All right, cool. Liquidation price is this times this. Okay, 18. All right, cool. Now the liquidation price is 18. Can be liquidated. This is the current price. Let's put current price at 12. Okay, let's do if liquidation price is, it says if logical expression, if liquidation price is greater than or equal to this, value if true should be, let's call it, there's no boolean. Okay, let's just say true, otherwise say false. So we can see here that at this current price you can't liquidate an asset. Yeah, now let's copy everything that is here and bring it here. Good, but this time around the current price drops to 18. What do we find? Can be liquidated becomes true. Now once the current price is 18 or less than 18, we find that we can liquidate. So even if it's 17.5, can be liquidated, it's true. So we already store this in storage, so we don't need to compute this on the fly. So the only thing that our can be liquidated needs to know is it needs to be able to get current price, but it needs to get it not as like an argument, it needs to get it internally. Because if you get it as an argument, someone might just pass in a price that they like, and this would always be false. Okay, so we need to write our can't be liquidated function to call a mock oracle internally and compare it against the liquidation price. So what we need to do is come here, can be liquidated. So the very thing is, one, we do u in 256 get current asset price. Now, how do you do that? The first thing you do is you need to check the loans. Okay, once you get loans, put in loan ID. Okay, we have loan ID. Loans has a bunch of fields. Can we view them from here? We can't. We have to go up. Oh, Solidity needs, I mean, whoever designed this thing needs to do some work. Loan. So let's go to data types. We're looking at loan. So we want to look at params, and we want to look at collateral token address. We also want to know the liquidation price. Okay, so first thing first is come back. Before we do that, okay, this is params, this is liquidation price. Okay, but we also need to know address of collateral token. All right, and then we can access it from the same object but with a different field name. Good. So now we can use our mock oracle. This is liquidation price. Okay. The current asset price in 256 current asset price is equal to collateral token imoc oracle dot get asset price, which is this, and then get asset price takes in collateral token. Okay, current asset price. All right, and we need to run a simple check. Is return liquidation price less than or equal to current asset price? If it is, return true, otherwise return false. Done. This is our can be liquidated function. Okay, no drama. All right, we use this, we're done. Now let's come to the swap collateral asset for a stable asset. I have something here. Let me just blow it up. Okay, so most swaps, before I do that, most swaps happen on this website. Uniswap v3 swap. So on this website, you can say, oh, I want to exchange 56 Ethereum for USDT, and it will quote a price for you. You know, the price is based on a relationship between these two assets. Okay, this is standard. This is a very common thing in Web3. So what we provide is we provide the units of assets in the collateral token, and then we get the unit of assets in like a stable token, which will be actually the value, you know, which is the value in dollars. You can see that this is the same as this. If I use the different assets and I say, okay, I wanted to wrap Bitcoin, you can see the unit of assets is different, but the value is the same. Okay, but for a stable token, it's going to be the same. All right, because you know, short of like tiny changes, which is this is just due to exchange rates. Okay, so the interface that we're looking for is, it looks like this. Basically, it takes in quote exact input single, tells you how much token out you receive. Okay, so basically you provide the address of the token you want in, which is our collateralized token. Then you provide the address of the token out, which is the stable coin. Then you provide the amount of the token in, which is the collateralized, the amount that is in has been collateralized. And then, so you provide a fee and you provide this value as well. This is like your price, and this is like a fee. So I think they do an example here, sort of. They use square root price limit 0. So they use this is some price measure actually, and then the fee they use pool fee. I don't know where you get the fee from, but they pass it in. But for our example, what we are going to be executing is we are going to be executing this swap exact input single. So we'll put in the amount of token in. No, actually, we're not going to put in the address of the token, the collateral token, the address of the stable token out, and the amount in. And then I'm not going to add these two. All right. So we're going to write what looks like this, a function that looks like this without these two fields. So let's just, before I do that, let's create, I don't want to use mock oracle again so that you don't confuse the two, because I'm going to do something where I integrate third-party apps where I'll be replacing mock oracle with an actual oracle, and I'll be replacing a swap with an actual swap. But in the meantime, because I'm using mock oracle, which I need for testing, I'm going to then create another interface called iswap.sol. Okay, I'm just going to copy all the standard mumbo jumbo here. I'm going to say interface iswap. Okay, and iswap is going to have this. All right, so we just copy this out in here like that, and then we take these two out. I'll only bring this back in, when it's time to bring them back in. So maybe what I do is I just comment it out because I don't need it right now. Okay, so when I do need it, I bring it back in. All right, so iswap. Now we need to bring iswap into our market. Okay, we've done this several times. So import iswap from iswap. Okay, now one thing that we need when you're doing like an interface swap, obviously, you need an address, because for the oracle we created oracle address, so we need to add a swap address as well. So address public, let's call it swap platform. Okay, in the future we'll probably call this Uniswap or something, but for now we make it generic swap platform. So what does swap platform do? Swap platform takes in address of token in collateral. So let's just change this to collateral token asset, stable token out, and the amount in, which is the let's call this collateral token quantity. All right, so there is no confusion. All right, and we use this exact same thing, so we can change the name of the variable, doesn't matter as long as the types are the same. So we come in here, where do we go next? Here. So we need this for this, right? Obviously we need to do some confirmation, right? It's kind of important that I feel like personally that this confirmation should actually happen here. All right, so confirm the loan ID exists. So to do that, a good way is we can say require that loan ID params dot time of borrow greater than 0. Otherwise, loan does not exist. Okay. Also, no, let's say invalid borrow time. Okay. Another thing we can do is we can use this actually. We can say require this is not equal to address 0, and we say invalid collateral token, so fail. Okay, all right. And then we also need to require that it has a liquidation price, because we also check this. Yeah, so require this is greater than 0, otherwise invalid liquidation price. So we have run our checks. All right, so we run. Now we need to check if the loan is active. Yeah, final one is require that this time around it's current status, so it's loan dot current status is equal to loan states dot active. Loan states must be active. Boom, all done. So we've checked. I know this is a view function, but it's kind of important for us for all those things to be actually. We can move this away. You know why? Because can be liquidated should be false. So like if let's move this away. The reason why I want to move it away is because all this are necessary to calculate this here, but loan states active is not necessary. Okay, so we're going to move that loan state to here and put it here. Okay, and we've confirmed that the loan is ID is this and that and everything. So basically, a person can check if a loan can be liquidated, and it would return. I don't quite like this. I don't quite like the decision I just made. I think I want to backtrack. A loan should not be able to be liquidated if it is not active. So I'm going to add one more state. Okay, one more state. Okay. Let's do is bool is active. Okay, let's say loan ID dot current status is equal to loan state dot active. Okay, so what we want to do is we want to check two conditions. We want to check that the liquidation price is less than the current asset price and the loan is active. Yeah, that's what we want to do. So if this is false, you can't liquidate, because true and false means that for and you want both conditions to be true. So for and to be true, one, if you have 0 and 1, it's 0. If you have 1 and 1, yes, you know. So for you need so if you have 0 and 0, it's also 0, you know. In each case, this is false and this is false. This would be false. Okay, so this is what we want. We want liquidation price to be less than current asset price and the loan is active. Now, yeah, this is good. So this handles what I wanted to do, the require statement. So basically that means that all these 3 checks, we have done all these 3 checks in this. So require that the loan can be collateralized. So at this point in time, we have 2 options. We can either allow an if check, in which case, if the loan cannot be liquidated, nothing, it doesn't fail, which is not very good. I think it should fail. So require can be liquidated to be true. Otherwise, it says loan cannot be liquidated. Done. Okay, so we've handled all our conditions. Now let's handle our swap. To do our swap, um, we need to require that swap platform is not equal to address 0. So the address has been set. Set swap platform address. Okay. All right. I swap. Oh my god. If you're from Nigeria, this hits differently. Oh my jeez. Oh my days, bro. Oh my days. This takes in 3 inputs. What's the first one? The first one is collateral token address. So the first one is this. So let me get the address collateral token. All right. Stable asset. So we'll do address for stable asset, okay, because it's an object. And the units collateral token quantity. We need the collateral token quantity. Urine 256 collateral token quantity is equal to loan ID dot params chime in. So do swap input doom, and this obviously returns like an amount out. So let's just copy this out, and then we say this. Okay, so now we have to do some accounting. The first accounting that we need to do is we need to repay loan. So there is a check that needs to happen here. So here's what I'm thinking about. There's a scenario in which the value of the asset can drop so fast that the actually that's irrelevant. It doesn't matter. Amount out. So what we want to do now is we want to repay the loan. Okay. So if you look at our repayment function, um, the first thing is we reduce. So borrowed, we reduce the amount from what this guy has borrowed against. So I need to think. What's the most important thing to swap first? Because I already have the amount. I mean, we need to repay, but we need to close the loan because right now the loan is open. So the very first thing is let's just first close the loan, okay? So let's change the loan ID dot current status. Let's change it to loan states dot liquidated. Okay. First of all, we've closed the loan. Then we need to regularize the borrowed amounts for that user. Let me come here and think. So we are using we're going into the borrower info and we're making changes. Do we have the borrower's address? Yes, we do. So let's get the borrower's address. Okay. Address of the borrower is borrower. Okay, cool. Then we go into the borrower info. We pass in the borrower address, and then we access the active loan count. We want this number to be reduced by 1. Okay. We also want the borrower dot liquidated count to be incremented. Okay. Then we also want actually there's one check. I want to do here. If I mean this is just because some people are so super malicious that they can find a way to break your system. So this is just like me ensuring that this liquidation doesn't fail. This is like just de-risking it. There's so many like ways in which a person can attack you. They can find a way to have a loan where the active loan count is 0, and when you try to do this, it would fail, and then you can't liquidate them. People can find all sorts of crazy ways. So this is just to guard against that scenario. It doesn't really happen because every time a person borrows, we increment, but this is just to guard against the possibility of someone messing around. Okay. If borrower info dot liquidator count is okay. The next thing is borrower info borrower dot we need to ensure that borrowed for collateral token. So if you're going to look at borrowed collateral, so we want to reduce the amount here. So we're going to do reduce the amount by amount out. Okay. And once we do that, we also so what this does is this executes a swap. The interesting thing is it should be doing a swap on this. So it's taking the collateral token and yeah, from here, from this. So it's taking the collateral token from this contract, and it's doing the swap and returning the asset back to this contract. So we've already swapped. The amount of stable tokens has already increased, because we have managed to swap this collateral token for at this point. So it's already happened. So once we do all of this, the loan is technically repaid already. So the earnings are also distributed because okay, yeah, now amount out, we need to split this amount. Okay, so different people get amounts of money. So the first set of person who gets is the the LPs get 40%. LPs are the lenders. Lenders get 40%. Treasure. Let's give treasury 40%, and then let's give liquidator 20%. This is probably the highest I've seen a liquidator earn ever, but this makes your app really competitive. All right, so we have 0 0.4, 0 0.4, and 0 0.2. So how do we distribute this? So I think the best way to do this is to write a function that takes in an amount and splits it 40, 40, 20. So we're going to write that function in a library, our library, and then in the next video we are going to wrap it up. Okay.